Good evening, everyone. Am I audible?
Yes,
Yes,
sir.
sir.
Okay. So what was the last concept we discussed? I remember we doing some problem based on capacitors, right? Today, though we are supposed to start with current electricity, right? We will complete the capacitors part and then go to the current electricity part. Clear? So, shall we get started?
Yes, sir.
Okay, listen. So you're able to see my screen, right? So did we do problem based on capacitors in series and parallel? Did we?
No, sir.
Right. Okay. So we know what happens in a series combination, right? So when we talk about the capacitors connected in series, what is common among all the capacitors? So we know the formula of equivalent capacitance, that's a different story. But the question is, how will you find or how will you know that the capacitors are connected in series? What is important?
Same current.
Same?
Current.
What current? Direct current or alternating current?
Direct.
But a point to be noted here is capacitors will not allow direct current to pass through them. So it's not same current, it is same charge. Same current is a concept applicable for resistors. Okay. So remember, if you don't know, please make a note of this. Capacitors do not allow direct current to pass through them. Okay. So when you talk about series combination of capacitors, the same charge is going to be present across each capacitor. Next is parallel connection. So when we say parallel, what is common? It is the same. Answer, please. Same.
Potential.
Actually speaking, same potential difference. Right? So in a series capacitor, charge on each capacitor is the same. There is a charge supplied by the battery is equal to the charge that is present on each plate of the capacitor, but potential difference will be different. Whereas in parallel combination, potential difference on each capacitor is same, but the charges on the capacitors may be different. They use the word maybe because if all the capacitors are of equal capacitance value, there is a possibility that the charge will be the same also. So that is the reason why they use the capacitors may have different charges, right? So having said this, let's look at the first problem. There are two capacitors of capacitance. Okay, before that, how do you find the equivalent capacitance of capacitors in series? 1 by Cs is equal to 1 by C1 plus 1 by C2 plus so on till 1 divided by Cn. This is for the capacitors in series. Parallel is Cp is equal to C1 plus C2 plus so on till Cn. This is for the capacitors in parallel, right? Next. So let's say there are two capacitors of capacitance 6 and 12 microfarad which are connected in series with the battery. The voltage across the 6 microfarad capacitor is 2 volt. Compute the total battery voltage. How to do this? So 6 microfarad, 12, both are in microfarad. They are connected across.
So,
Tell me.
sir, first we can calculate the charge across the 6
What?
microfarads. So we know that since they're connected in series, the charge would be same.
From there, you calculate the potential difference and add them.
Yes.
Right? Correct. So if I take this, right, they have given the capacitance. So what is the relation between charge, capacitance, and potential difference? Q is equal to CV. So C is 6 into 10 power minus 6 into V is how much 2? That is going to be 12 into 10 power minus 6 coulomb, right? So having said this, the charge here is also supposed to be the same. So across the second, so this is across the first capacitor. So across the second capacitor, if I take Q is equal to C dash into V dash. So what is the value of Q? It is 12 into 10 power minus 6 is equal to C dash is 12 into 10 power minus 6 into V dash. 12 and 12 will get cancelled. So V dash is equal to 1 volt, right? So V dash will be 1 volt, right? So what is going to be the total potential difference?
3 volt.
So that is 2. So here it is already 2 volt plus here it is 1 volt. So 2 plus 1 is going to give you 3 volt. So the total potential difference applied with the battery is 3 volt. Clear? Shall I proceed?
Yes, sir.
Sorry, somebody. Okay. So 3 volt. No, try this. Two capacitors, 3 microfarad and 6 microfarad are charged to potentials 2 volt and 3 volt, 5 volt respectively. These two charged capacitors are connected in series. Find the potential difference across each of the two capacitors now. So two capacitors of capacitance is 3 microfarad. So C1 is equal to 3 microfarad and V1 is equal to 2 volt. C2 is equal to 6 microfarad and V2 is equal to 5 volt. So what is the value of Q1? Q1 will be equal to 6 microcoulomb. What about the value of Q2?
Thirty
So
micro.
3 into
30,
approx.
30 microcoulomb, right? These two charge capacitors are connected in series. This is what is important. Listen to this carefully. So this 3 microfarad and 6 microfarad are connected in series. Right. Now, when they're connected in series, what should happen here? Here the charge is
The
6
charges will try to get to the other capacitor.
try to get, I want that word. Charges will get,
Transferred. Move.
rather charges will get redistributed.
Yes, sir.
So the charges will get redistributed in such a way that what will be the charge on each capacitor? So I would like to write the story here. So what is happening from the question I'm able to understand? They are connected in series. So series means what should happen? Charge should be the same. But initially what is happening? Charge is not the same. So charges will get redistributed. Shriram, can you tell me how they will get redistributed?
Sir, each capacitor will have now 18 microcoulombs.
How do you know?
We add both and divide by 2 since there are two
Because
capacitors.
we have 2, we need to take the average of both. Very good. So that is going to be 36 divided by 2, which is going to be 18 microcoulomb. Am I clear with this, guys? So this capacitor and this capacitor is going to have 18 microcoulomb of charge. Now, since you know the charge on each capacitor, is it possible for you to calculate the potential difference? So what will be the value of V1? V1 will be equal to Q1 by C1. What is the value of Q1? 6 microcoulomb divided by C1 is, oh, sorry. 18 microcoulomb divided by 3 microfarad. Is there anyone who's not able to understand what is happening? Is there any step that is not clear? Please get it clarified. So here I didn't substitute 6, I substituted 18 because after the redistribution only I have to calculate the potential. So this is going to be 18 microcoulomb divided by 6 microfarad, which is going to be 3 volt. Am I clear with these 2 points?
Sir, I have a doubt.
Yeah, tell me.
Why are we taking average, sir?
Because that is when the charges will be same on both, right?
Okay, sir.
Hmm.
Sir, if there's like more than two capacitors, we again take
You
average.
need to take the average. You need to take the average, because that is the mean value, right? Which will have the same value for everything.
Okay, sir.
Got it?
Yes.
Shall I proceed?
Yes, sir.
I think I made a mistake. 1 minute, guys. I'm sorry. So I'll do this problem again. Please listen, okay? There is a mistake. One minute. Listen. So this is how much 6 microcoulomb and this 30 microcoulomb, right? Now, what is the total charge supplied by the battery?
Sir, 6 and 3 microcoulombs. Sir.
The total charge supplied by the battery is 6 and 30 only, no?
Yeah, okay. Fair.
So 3 microfarad, this is 6 microfarad. Right? I made a mistake actually. Guys, listen, okay, I'm correcting myself. So total charge supplied by the battery is 36 microcoulomb, right? Now, this 36 microcoulomb will be the charge on each capacitor. I'm sorry, you should not find the average. So this will have 36 microcoulomb and this will have 36 microcoulomb, because when you talk about series connection, charges are going to be the same. So here, when I say the same, see, if I change it as 18, right? I'll tell you what is the mistake that happened. If I find the average, then I'm trying to say that the battery has supplied only 18 microcoulomb. But what is the total charge supplied by the battery?
36 microcoulomb.
It is 36 microcoulomb. So we can't account. So just because you put 18 here and 18 here, it doesn't mean 18 plus 18 is 36. No. So 36 is the total charge supplied by the battery. Now what will happen is, once you connect the 3 microfarad and the 6 microfarad together, each will have 36 microcoulomb. Okay, you should not find the average. It was my mistake. I'm sorry. Okay. Average should not be found.
Sir, I have a doubt.
Tell me. Yeah.
Sir, but after connecting the capacitors in series, we aren't supposed to draw a battery in the diagram, right? We just have to find the potential difference across that.
You'll find the potential difference. But the question is, what is the total charge that is brought in by each capacitor?
Sir, but each capacitor is charged by a different cell, right? Or battery.
Yeah,
Because they have different potential.
But when you connect them in series, what is the total charge that the system has? What is the total charge the system has? It is 36,
Sir,
right?
that is the sum, I agree, but then the cell also, we can't, like, we would have to connect the cells in series as well, right?
That's why here the potential difference will be V1 and V2 only. I didn't redistribute the potential at all, no? See, I'll tell you what has happened. Now tell me. This is 3 microfarad. This is 6 microfarad. Okay. This is charged to 6 microcoulomb. This is charged to how much? How much was it? 30. 30 microcoulomb. Now, when you connect them in series, right? Now, what is going to be the total charge? It is going to be 36 microcoulomb. Okay. Now, when you connect them like this, right? When you connect them like this, let us say you are putting only 18 microcoulomb here. You're finding the average and putting 18 microcoulomb here. Then where did the remaining 18 microcoulomb go? It is not lost. And this is the point they're asking. Find the potential across each of the two capacitors. Now means, now it is you're saying you need not draw that battery. Is this what your point?
Yes, sir.
But
Yes.
it doesn't make any difference. It doesn't make any difference. If I take that to be V, they're asking V1 and V2. Had the problem been in such a way that what is the total potential across the system, then this battery is needed. Okay, from this V only, you are getting this V1 and V2. Or I can put it in the reverse and saying that this has a potential V1 and this has a potential V2. The sum of both is what is this V? Okay, if this is what is bothering you, I can remove it. It is not mandatory, but at the same time, you cannot say you should not draw it. You can. Okay. So now you're okay. This is what you're saying. This is
Yes,
V1
sir.
and yeah. So our job is to find V1 and V2. But my point is, did you all understand that why we are not supposed to find the average? Average should be found only in the case of connecting them in parallel, because in parallel only charges will get redistributed. I'll teach you how to do that also. Is this point clear?
Yes, sir.
Yes, sir.
Yes, sir.
So you should take it as 36 only. So 36 microcoulomb here, 36 microcoulomb here. What is the value of V1? V1 will be 36 divided by 3, which is going to be 12. And what about V2? 36 divided by 6, which is going to be 6 volt. Are you able to understand? So answer will be 12 and 6. This is the right answer. Am I clear?
Yes, sir.
Two capacitors have capacitance 5 microfarad when connected in parallel and 1.2 microfarad when connected in series. Calculate their capacitances. Solve. Let the capacitances be C1, C2. When they are connected in series, what will be the equivalent capacitance? It will be C1, C2 divided by C1 plus C2. Am I right? Why is it so? Because 1 by CS is equal to 1 by C1 plus 1 by C2. So 1 by CS will be equal to C1 plus C2 by C1, C2. Take the reciprocal of it. So what should I do in the place of CS? It will be 5 microfarad is equal to C1, C2 divided by, what is C1 plus C2, guys? It is 1.2 microfarad. So what is the value of C1 into C2? That is going to be 5 into 1.2, which is 6. So unit will be microfarad, the whole square. Generally, we need not write it. So C1, C2 is 6. So C1 plus C2 is 1.2. C1, C2 is 6. Okay. Then how do I solve this?
Sir.
Mhm.
Sir, could you please go back to the previous sum? I just needed to. So what is the charge, I mean, potential before connecting? Like, could you go to the question
That's
once?
2 and 5.
Okay, sir. Thank you, sir.
So C1 plus C2 is 1.2. C1, C2 is 6. Now, how do I solve this, guys? Can I write C2 is equal to 1.2 minus C1? Take this and substitute it here. C1 into 1.2 minus C1 is equal to 6. So C1 square minus 1.2 C1 plus 6 is equal to 0.
Sir, capacitance in parallel is 5 microfarad.
Oh, when connected in parallel, I'm sorry. I didn't see that. Obviously, that should be more. This is 1.2 and this is 5, correct? So this is going to be 5. C1, C2 is still going to be 6 only. So C1 plus C2 should be equal to 5. Now I think it is easier to solve. That will be 5 minus. Somebody's mic is on.
லீவு சொல்லு நாளைக்கு காலையில 4:30 வரணும்.
So
Sir,
tell me.
sir, I have a doubt in the previous.
1 minute. I'll finish this, then you can go. So
Okay,
5 minus C1. So 5 minus C1 means C1 square minus. What is the answer, guys? Did anyone get it? Minus 5
Sir,
C1
it's
is
3 and 1, 3 and 2.
So C1 minus 6 into C1 plus 5 is equal to 0. So C1 6 were there. Oh, 6 were there. 3 and 2. Correct. 3 and C1 minus 2. So C1 is 3 or 2. Correct. 3 comma 2 is the right answer. Because 3 plus 2 will give you 5. 3 into 2 by 3 plus 2 will give you 1.2. Correct.
Yes, sir.
So C1 is 3, C2 is equal to 2, or you can take it in reverse also. We don't know which one is what. Okay. So I hope everyone understood this.
Yes.
Clear? 1 minute. So if you're done copying, I'll clear his doubt.
Sir, 1 minute.
Yeah.
Sir, microfarad square, where it comes in?
Come again.
Sir,
What
that
did you ask?
microfarad square, whole square.
That is because C1 into C2 is there. No? See, that's you know not write it actually. Okay. Because this is microfarad, this is also in microfarad. When they get multiplied, you will get microfarad square. Got it?
Yes, sir, but while equating, we are not taking into account, right?
Which one? No. Here,
Yes, sir.
no, see, our job is to find individual capacitances, right? Why would we be concerned about C1, C2? It is only a mathematical part. That is why I didn't write the units. See, if at all you want to write the units, I just gave you a safety measure. So if at all you want to know what is the unit of C1, C2, it will be microfarad, the whole square. That's it.
Yes, sir.
Got it?
Yes, sir, got it.
Tell me, what is your doubt?
Sir, if we take into account 36 microfarad in this sum, like the total, the total charge, then energy isn't conserved, right?
Here, energy is not conserved, no. It is the total charge that is conserved. And why should the energy be conserved in a capacitor? Capacitor releases, no. Capacitor will lose the energy in the form of heat.
Sir, but how can the total energy after the system, like the total energy of the system, be greater than before it is connected?
Because you brought in two systems which had more energies, right? That is the reason. Individually, what did you do? You took a 3 microfarad capacitor, charged it separately, 6 microfarad capacitor, charged it separately. When you bring them together, the system is obviously going to have greater energy. You're able to understand?
Yes, sir. Understood, sir.
Yeah. One minute. Somebody has logged in the name of Vasu. Please change it. You won't find a student name there.
Yes, ma'am. Sir, I'm Yuvan, sir. Yes, sir. Rename.
Yeah, you want please change it. Okay. Two and three. Yeah. Solve this. So two capacitors of equal capacitance, when connected in series, have net capacitance C1, and when connected in parallel, have net capacitance C2. What is the total? What is the value of C1 by C2? Answer. One step you can say. It's an MCQ. So both are of same capacitance. What will be the value of CS? C by 2. This
Sir,
is
it's
C1.
giving 3 capacitors.
Or 3 here. C. Then what is it going to be? C1 by 3 or C by 3? This is the value of C1. Cp is equal to 3C. This is C2. So what is the value of C1 by C2? 1 by 9. That's the answer. Right. See, this kind of a problem will not come. You don't have combination of resistors and capacitors. Okay. Now we'll do some problems based on energy stored in a capacitor. So energy stored in a capacitor is given by the expression half CV square Q square by 2C or Q into V divided by 2. So I hope everybody knows how to derive it. Derivation is basically by calculating the amount of work that is done to store the charge. Right, you can go through the recording for it. Next is energy stored per unit volume. That is the energy density of the capacitor is going to be half epsilon naught E square. Right. So energy stored in the capacitor is going to be half epsilon naught E square. Similarly, the electric field between the plates of the capacitor is going to be sigma divided by epsilon naught. So these are the 3 points that we need to make a note of. So I hope everybody knows this energy density. What is energy density? Energy stored per unit volume inside a capacitor is half epsilon naught E square. Okay. So based on this, let's do some problems. So two parallel plates separated by 2 millimeter of air have a capacitance of 3 to 10 power minus 14 farad and a charge and are charged to a potential of 200 volt. Then without touching the plates, they are moved apart till the separation is 6 millimeter. What is the potential difference between the plates? What is the change in energy? So let's take the initial data. What did they say? There are two parallel plates separated by 2 millimeter of air. Has a capacitance of 3 into 10 power minus 14 farad. So what is the value of small d? 2 into 10 power minus 3 meter. Capacitance is 3 into 10 power minus 14 farad. Potential is 200 volt. Am I right? Then without touching the plates, they are moved apart till the separation between them is 6 millimeter. So D dash is equal to 6 into 10 power minus 3 meter. Capacitance will change. Let me call it as C dash. Potential difference is still going to be. Yeah. So what is the potential difference between the plates in this scenario? Okay, I need to calculate it. Let's see how to do this. So how to calculate this? Just give me a minute.
Sir,
1 minute. One minute. Are you able to see my screen?
Yes, sir.
Tell me, you had some doubt, no? Please tell me.
No, not a doubt, sir. Yeah, sir. So C2, we can calculate C1 into D1 upon D2,
Yeah,
and then we can proceed, sir.
that's right. Because because C1 will be equal to epsilon naught A by D. C dash will be epsilon naught A divided by D dash. So C dash by C is equal to D dash by D. D by D dash. D by D dash. Correct. Which implies C dash is equal to C into D by D dash. This is what you told. So it is 3 into 10 power minus 14 into D is 2 into 10 power minus 3 divided by D dash is going to be 6 into 10 power minus 3. So cancel it 1/3. The answer will be 10 power minus 14 farad. Farad and microfarad. Farad. Okay. What is the potential difference between the plates in the new scenario? So how do I calculate V dash?
So we can calculate the charge in the first case, and
So
then
calculate
over
the
here we
charge.
can just substitute the value for.
How much is the charge? Q is equal to CV.
So 6 into 10 power minus 12.
6 into 10 power minus 12 coulomb, right? So V dash will be equal to 6 into 10 power minus 12 coulomb divided by, what is the value of V dash? C dash, that is 10 power minus 14. So answer will be 6 into 10 power 2 volt, or it is going to be 600 volt. Means the potential has actually increased 3 times. So what is the change in energy? Will you be able to calculate the change in energy? So how do you calculate the change in energy? So calculate the initial energy. Initial energy is how much? U1 is equal to half C1 V1 square. U2 is equal
So
to
12 into 10 power minus 12.
12 into 10 power minus 10 joule. Correct. So half C1 V1 square, half C2 V2 square. Calculate the difference. That will be the answer. So what is the value of half C1 V1 square you got? What is the energy for the first one?
So 6 into 10 power minus 10 joules.
Correct. What about this one?
18 into 10 power.
Correct. So 18 minus 6, it is going to be 12. Correct. Shall I proceed? Is there anyone who didn't understand? Okay, listen. Now do this problem. Find the equivalent capacitance between A and B in the combination given below. Each capacitor is of value 2 microfarad capacitance. So how many of you don't know how to redraw this circuit? If you can let me know, I'll help you.
Sir, this is just parallel capacitor, right?
Which one is parallel? Everything is in parallel. Huh?
No, sir. C1, C2, C3, and C4 are parallel,
Okay.
and C5 is in series.
Try to redraw and see.
Sir,
Tell me.
sir, can you teach us how to redraw?
Okay. Those who don't know,
Sir,
please concentrate.
C2, C3, and C4 are in series, sir. Sorry, parallel, sir. C1 and C5 are in series.
Series to whom?
C1 and then parallel. No, C1 is in series, and then C2, C3, and C4 are in parallel.
1 minute, 1 minute. Come again. Yeah. Say
C1 is in
C-
series, sir.
Okay.
C2, C3, and C4 are in parallel.
Okay.
And then C5 is in series.
Correct. So Shreyan asked me, can you redraw it as a Wheatstone bridge? No, it's not exactly a Wheatstone bridge. I'll tell you, see, whenever they ask you, the same logic is applicable for next chapter also. Those who don't know, listen. Those who know also listen. So find the equivalent capacitance or resistance means always a question should be between which 2 points. Okay. For example, the whole game would have changed had they told between the points A and P or A and S. So here, what did they say? Find the potential difference between the, find the equivalent capacitance between the points A and B. So always draw the endpoints separately. A here, B here. Listen. Now, P is there, S is there. Observe, P and S are connected with a wire. So whichever points are connected with the wire are said to be connected in parallel. Sorry, not, yeah, they're in parallel because they both have the same potential. So what you can do is, you can replace the point P with S. Means P comma S, if I write it, they both have the same potential. Similarly, tell me what other 2 points have the same potential? Which 2
R
other
and
points? Yes. So R and T are here. Now what you will do is, from A to P, how many capacitors are going? From A to P, how many capacitors are going? It is 1. So let me call it as C. Every capacitor is of value C or 2 microfarad, whatever it is. From P to R, see, from P to R, there is 1 capacitor going. Similarly, from R to S, there is an other capacitor going. Similarly, from S to T, S2T also, there is an other capacitor going. Are you able to understand this point? This is a crucial step. Yes or no?
Yes, sir.
Okay. So these C2, C3, and C4, we have redrawn them to be in the parallel connection. And from T to B, how many capacitors are going? There is 1 capacitor going.
1.
So everything is of value C. They gave it as C1, C2, C3, C4, C5, only for you to have an understanding when you're redrawing the circuit. Okay, so all these capacitors put together will give you a value of 3C. So what will be the equivalent capacitance? 1 by Cs will be equal to 1 by C plus 1 by 3C plus 1 by C. So how much will be the answer? I'll write it
Sir,
as
they are given 2 microfarad.
no, first we'll find the value, then we'll substitute it at the end. 7 divided by 3C is what is 1 by Cs, which implies Cs will be equal to 3C by 7. Now you substitute the 2. So it is 6 divided by 7 microfarad. Is it clear?
yes, sir.
Right. Next time you will be able to redraw, right?
Sir,
Tell me.
sir, between P and S, sir, there are 2 capacitors, no, sir. So it will have consumed some potential, no, sir. How are they both same potentials? Can you tell?
P and S are connected using a wire that is called short circuiting.
Okay, sir.
When you short circuit 2 points, right? When 2 points are connected with the wire, generally wires are assumed to be of 0 resistance. Okay.
Yes.
So when 2 points are connected with the help of wire, then they both are said to be at the same potential, or in other terms, you can say that the potential difference between those 2 points is 0.
Okay, sir.
Got it?
Thanks.
Yeah. Do the next part of the question, guys. If a DC source of 7 volt is connected across AB, okay, how much charge is drawn from the source and what is the energy stored in the network? So since you found the equivalent capacitance, guys, so how do you find the charge supplied by the battery? Q is equal to CV. C is how much? 657 microfarad into what is the potential difference connected? 7. 7 and 7 will get cancelled. Answer will be 6 microcoulomb. Am I clear? Now, what is the energy stored in the network? Energy stored in the network, I will use the formula half CV square. Half into C is 657 into 10 power minus 6 into V square is 49. This and this will get cancelled. So 7 and this will get cancelled with P. So 7 into 3, 21, 21 into 10 power minus 6 joule. So this is going to be the energy stored in the system. That is the network. Clear with this? Yes or no?
Yes, sir.
Okay, listen. Three identical capacitors C1, C2, and C3 of 6 microfarad each are connected to a 12-volt battery as shown. Find the charge on each capacitor. See, the C1 and C2, how are they connected?
Series.
So they are in series. So for C1, C2, equivalent capacitance is how much?
Please,
Each
3 micro.
3 microfarad. See, when you're writing the exam, don't directly write it as 3, you have to show the steps, okay? So 3 microfarad. Next is, so how will the circuit look like? A 3 microfarad connected across a 12-volt battery, which is connected across a capacitor of 6 microfarad. Right. Now, what is going to be the charge on this? Here, Q will be equal to CV. So 3 into 10 power minus 6 into V is 12. So that will be 36 into 10 power minus 12 coulomb. What will be the
36, 10 power minus 6. No.
Oh, 6. 36 into 10 power minus 6 coulomb. What is going to be the charge here? Q is equal to CV. That will be 72 microcoulomb. Correct. So
Yes,
what are
sir.
the equivalent capacitance of the network? Now tell me the C1, the equivalent of C.
9
How much?
micro.
How 9? They are connected in parallel. So CP will be equal to 9 microfarad. Right. So what is the energy stored in the network of the capacitors? So and the energy will be half CV square, half into what is the equivalent capacitance of the network? 9 into 10 power minus 6 into what is the value of V square? 144.
140.
So it is 72. So what is 72 into 9? 18, 1, 648.
48.
So 648 into 10 power minus 6 joule is the answer. Or microjoule, whatever you call it. Right? So these are all simple problems only. Shall I proceed?
Sir, can you show the previous slide? Sir, the charge on the each capacitor, it should be like,
It should be like
sir, here you wrote like 36 into 10 power something, right?
36 into 10 power minus 6.
This is the charge on C1 and C2.
That will be the charge, no? Because that is the total charge supplied by the battery to the both capacitors, which are in series. So listen, whenever you are asked to solve a problem where you need to calculate the charge on each capacitor which is connected in series, The only method is find the equivalent capacitance and multiply it with the potential across which they are connected.
Okay, sir.
So that is got it. For parallel only, what you can do is you can directly take the capacitance and multiply with potential difference, because in parallel we will have information about the potential difference because it's the same.
Yes, sir. Got it.
Do this, yeah. So in a camera flash circuit, a 200 microfarad capacitor is charged by a 1.5 volt battery cell. Okay. When a flash is required, the energy stored in the capacitor is discharged by means of trigger T through a discharge tube point in 0.1 millisecond. Find the energy stored in the capacitor and the power of the flash. So will you be able to calculate the energy stored in the capacitor? It is half CV square. We need not worry about the story. So half into 2000 into 10 power minus 6 into what is the value of V square? 1.5 the whole square. So it is going to be 3 by 2 the whole square. So it will be 1000, that is 10 power minus 3 into 9 by 4. That is how much? 2.25 into 10 power minus 3 joule. Similarly, they are asking power. So how do you define power as? Amount of work done per unit time. But here the work done will be stored in the form of potential energy per unit time, potential energy. So what is the value of U? 2.25 into 10 power minus 3 divided by what is the time, guys? 0.1 millisecond. So 0.1 into 10 power minus 3. Cancel them. Answer will be 22.5 watt. Is this point clear?
Yes, sir.
It's a simple problem actually.
Sir,
Tell me.
can we use power as voltage into current? It'll be big, but is it correct, sir?
Power is equal to voltage into current. Here, I told you, capacitors will not allow current to flow through them. Why do you want to use I?
Okay.
Yeah. See, power is equal to V into I is the electrical energy. Okay, accepted. Okay, but don't use it here. Yeah.
Yes, sir.
Shall I proceed? So 800 picofarad capacitor is charged by 100 volt battery. So capacitance is 800 into 10 power minus 12 is charged by a potential of 100 volt. After some time, the battery is disconnected. The charger is connected to another 800 pico, and the capacitor is then connected to another 800 picofarad capacitor. What is the electrostatic energy stored? So let's analyze the situation. Initially, what is happening? There is a capacitor. So this is similar to the NCRT textbook, NCRT solved example. Okay. So you have 100 volt here, 800 picofarad here. Now my question is, okay, what is going to be the charge that is getting stored on this?
Sir, 8 into 10 power minus 8.
It will be 8 into 10 power minus 8 coulomb, right? Now what is happening? This capacitor, which is having 800 picofarad capacitance, potential of 100 volt, and a charge of
Amma.
So 800 picofarad, 100 volt, and 8 into 10 power minus 8 charge is connected to another 800 picofarad capacitor. Now what will happen is, this charge, now it will get redistributed. Now you can use it because these two are said to be connected in parallel. Why did I say parallel? Because if there is a positive charge on this plate and negative charge on the other plate, here also you'll have positive and here also you'll have negative. They're said to be connected in parallel. So when they are connected in parallel, tell me what is going to be the same between them?
Potential difference.
Potential. So what is the total? Initially, the potential present on the first capacitor is 100 volt. So charge, I want everybody to make a note of it. Charge will get redistributed till the potential on each capacitor is the same. Right? Here potential will be V, here also the potential will be V only. But how to find the common potential? V will be equal to, C1 V1 plus C2 V2 divided by C1 plus C2. So basically, what is C1 V1? Charge on capacitor 1. C2 V2 is the charge on the capacitor 2 divided by the equivalent capacitance, that is C1 plus C2. So what is the value of C1 V1? That is 8 into 10 power minus 8 plus. What is the value of C2 V2? Initially, the potential difference across the second 800 picofarad was 0 divided by what is the value of C1 plus C2? That will be 1600 into 10 power minus 8. Cancel this and this. Sorry, 1600 into 10 power minus 12. Is there anyone having doubt in this? So 8 divided by 1.6, which is obviously going to be 50. See, in this problem, you need not solve it because they both are of same capacitance. Rather, the potential will be exactly half of each. That is 100 plus 0 divided by 2. It would have been 50 and 50. But you will get stuck if this capacitance and this capacitance were different. Okay. So 50 volt here, 50 volt here. Now, what you will do is what is the electrostatic energy that is stored? So energy on the first capacitor is how much? Half C1 V1 square plus what is the so I'll write it as U total is equal to U1 plus U2. So what is the value of U2? Half into C2 into V2 square. So if I take that half outside, what is the value? I can actually take V square also outside because the potential is the same. So if I take that V square outside, what is the value of C1 plus C2? That is going to be 1600 into 10 power minus 12. And in the place of V, you substitute 50 square, and then you calculate the final answer. Tell me how much is it in terms of joule?
Sir, why are we taking C2 V2 as 0, sir? Can you tell us?
Why are we taking?
C2 V2, that part 0.
Where? Here.
Yes, sir.
The place where I circled.
Yes, sir.
Okay. See, if this capacitor is of capacitance C1 is connected to another capacitor of capacitance C2, let's say the charge here is Q1 and Q2. Okay.
Yes, sir.
Now, initially, when they were not connected with the help of a wire, they both would have had different potential. I would have called the potential here as V1 and V2. Now, as soon as I connect them, then I'm using a conductor. So what does a conductor do? The conductor allows the charges to get transferred from one to another.
Yes, sir.
When I do that, the potential of both will not be same anymore. Will not be V1 and V2 anymore. Because when the redistribution is taking place, when will redistribution take place? When there is a potential difference.
Yes,
Right.
sir.
So the redistribution will take place till this and this have the common potential V. Am I right?
Yes, sir.
Now you tell me one thing. Initially, what was the charge on the system? Charge on the system.
Q1 plus Q2.
Q1
yes, sir.
Q2.
C1 V1 plus C2.
C2 V2. What is the final charge on the system?
Q1 plus Q.
P1V plus
Plus C2V.
C2V. So here what happens is, if you treat this as an isolated system, what do you mean by isolated system? Means the charges cannot interact with the surroundings. If you treat it as an isolated system, what is conserved?
Charge is conserved.
Charge is conserved. So initial charge C1 V1 plus C2 V2 should be equal to the final charge, that is C1 plus C2 into V.
Yes, sir.
For V another. That is the reason why
Okay,
I took
sir.
C2. Okay, it is because of the concept of conservation of charge.
Yes, sir.
Is it clear, guys?
Sir,
Actually, I was
so
Tell me.
V1 will keep on decreasing and V will keep on increasing until they become equal, right?
yes.
Okay.
Okay. So this is all about energy. I'm supposed to do problems based on capacitors filled with dielectrics and conductors. So after that only we can say that this chapter is over. Okay, there are few more problems that I need to do, which I'll do it in the next class. Okay. So let's not worry about, I'm supposed to start magnetic effects tomorrow, but you don't have it for the first test. So let's not worry about it. Okay. So let me complete this portion tomorrow and then I'll start current electricity. Okay. Shall we wind up?
Yes. Yes.
Sir,
Yeah, tell me, ma'am.
sir, in the last question,
Which one? That
so the last one that we did.
This one, huh? Oh no,
No, sir.
this one.
Yes, sir. Can I see the question? Sir, to another capacitor, what if the other capacitor is not charged, sir?
It is not charged. Means it initially had a potential of 0. Means it initially had how much potential? 0. That is the reason why I took the C2V2 as 0 here. Understood what I
Okay,
did?
sir.
Got it?
Yes.
So I'll tell you one thing. I just want to mention this point. Capacitor, what is the job of a capacitor? To store the charge. What does a battery do? Battery also stores charge. It supplies whenever you close the circuit. Right. So in this problem, what they did is they initially charged an 800 picofarad capacitor, and they used that as a battery to charge an other uncharged 800 picofarad capacitor. Got it?
Sir,
when
but
this
it's not given uncharged in the question. No, sir.
So they're connected to another 800 picofarad. By default, it is understood that it is uncharged.
Okay, sir.
Or else they would have seen this capacitor is connected in the sense the capacitor itself is charged because it takes the potential from here.
Yes,
It
sir.
is taking the potential, and with that potential, it is storing some charge and is giving charge to the other uncharged capacitor. They will not give you uncharged every time. You should understand.
Okay, sir.
Okay. Yeah. Clear. So shall we wind up?
Yes.
Oh, I see.
Thank you, sir. Sir?
Thank you, sir.
Thank you, sir.
Sir?
Um,